Hey, it's Clay. Welcome to another video. This is going to be a Frankenstein experiment. So if you have an aversion to taking golf iron sets from the 1990s and tinkering with them beyond the point of recognition, avert your eyes now. But if you do like to experiment and MacGyver some things together for fun and games, stay tuned. What we're going to do is we're going to take this Mizuno Zoid Pro set of irons and we're going to turn it into more of this. This is going to be a custom one length set a la Bryson DeChambeau. Let's go ahead and dive in. Hey guys, welcome to another video. This is going to be a custom one length build experiment. If you guys are familiar with one length irons, they've kind of become popular with Cobra via Bryson DeChambeau. The concept is actually very simple and straightforward. You have a static length of about 37 inches, which is about the length of a 7-iron. Seen different manufacturers, you can go up to maybe 6-iron, you can go down to about 8-iron. But I think for my purposes, I'm going to go with about a 7-iron length, which for me has always been very comfortable. Next, you take all of your heads and they need to be a static weight of, I'm shooting for somewhere between 270 to 275 grams of head weight. And that's going to be part of why what I showed you guys earlier was this 3-iron. You can see this thing is covered in lead tape. And that's because in a variable set of irons, when you have longer shaft length, you need to compensate by lightening the weight of the head. Otherwise the club would be extremely heavy. And so, this particular head I think weighed in at about 235 grams. So to get it up to 275 grams, I needed to add about 40 grams of lead tape to the head. And we'll explore some of the different ways that you can do that. But basically now while this is a 21 degree 3-iron head, it weighs the exact same as a 7-iron, and it's got a 7-iron shaft in it. Lastly, we need to talk about lie angle. When you have a shaft that is longer, that is going to produce more of a flatter swing plane. So your lie angle is going to be bet flatter to compensate. Meanwhile, if you have a club that's more upright, like a 7-iron, your lie angle is going to match. And so the lie angle needs to be adjusted across all these heads to be a static, I think it's about 62 degrees of lie. Now, I'm going to probably play around with that. My swing tends to benefit from clubs that are slightly upright. So I'm going to make all my 3-3 pitching wedge here in the single length the same static lie angle, a little bit upright. And then lastly, we're going to talk about loft. Now this is a 3-iron with 21 degrees loft. I believe that with this set, it goes from 21 degrees in the 3-iron to 47 degrees in the pitching wedge, which is, in my mind, kind of a traditional loft setup. There's about 4-degree gaps on the low end, so it goes like 47, 43, 39, 35. And then somewhere on the line, it goes into 3-degree lengths, right? So it's 21, 24, 27, and then somewhere in the middle, it kind of evens out. With single length, there are also going to be changes in ball flight. So when you take a 3-iron head, 21 degrees loft, and you stick it on this short shaft, you are going to be reducing your club head speed, right? When you have a shorter lever, at the end of the lever is going to be less velocity. And so with less club head speed, there's going to be less ball speed to launch the ball up in the air. And so you may find that if a 3-iron is at 21 degrees loft and a 4-iron is at 24 degrees loft, because a guy like me with an average club head speed is not necessarily launching the ball up in the air super high, I may need to experiment with those gaps and increase the loft gap between my 3, 4, and 5-iron. 3 degrees might not be enough. I've seen some manufacturers that even go to about 5 degrees of loft gapping almost all the way through the entire set. And so loft is going to be something to play around with as well. So let's go ahead and jump in and get started. We'll take a look at the clubs, we'll talk about what steps we need to take, and we'll dive into the build. Let's go. Okay guys, these are the irons we're starting with. We've got 3, 4, 5, 6, 7, 8, 9 wedge. Again, these are the Mizuno Zoid Pro irons. They're actually in pretty good shape. This is the pitching wedge. Now as you can see, the 7-iron is already off. That's because the shaft from the 7-iron I put in the 3-iron. The 3-iron I've already built out. This was just because, to be honest with you guys, this has been a little bit of a on-the-whim experiment or test. I really haven't thought this through deeply, but it's just something I really would like to try. I'm very interested in the concept and want to give it a shot. So I started with the 3-iron, and I'm going to show you the process of how I'm building out the rest of the clubs. So step 1, we need to get them all into just the head form. So we need to take the shafts and the ferrules off of the rest of these irons, and to do that we're going to take a propane torch and nuke them. Alright guys, as you can see now I've got all my heads laid out here. I got my 3-iron right there, and I've got a gram scale. This is just a kitchen scale that is capable of weighing grams. My unit of measurement is set to grams. See, the screwdriver weighs 14 grams. Okay, so the idea is, this is my 7-iron head, and we measure this. It's coming out about 266 grams. So I think I said before my target was 270. That's close enough. So we'll call it 266. Okay, so now what I need to do, we'll start with this. This is the 4-iron. You can see the 4-iron weighs 249 grams. So I need to get this up to 266 grams to match the 7-iron. So I'm going to be using, now in my estimation, there are 3 ways that you can add weight to a head, maybe 4. The first would be to put tip weights in the shaft. I've got a shaft here that has a tip weight in it. It looks like this. I don't know if you can see it or not, but there's a little silver plug right there, as opposed to a regular shaft with no tip weight. You can just see into the shaft. So you can use tip weights if you want. Now, tip weights are probably good to about 10-ish grams. If you start putting more weight than that, it's going to pull the center of gravity towards the heel and make it kind of more of a draw bias, right? If you've got like a TaylorMade M5 head that has an adjustable weight, it's just the same as adjusting the weight towards the hosel. I don't really want to do that, so I'm not going to do that. Second step would be to apply lead tape, like I've done here. Lead tape is nice because I can apply it on the head, and I can actually apply it wherever I want. I even put some here on the bottom of the sole. The issue is it doesn't look particularly good, but to be honest with you guys, that's not really a concern of mine. These things are going to look ugly. You can see this one's got like some epoxy stuff here that I need to probably get rid of, but I don't really care how these look, and frankly I think it's kind of neat if they look like Frankenstein's. So that's the next way that I could do it. Now the last couple ways, one would be to use these little weights. These are actually hex weights. This is a 10-gram weight that's actually meant for one of my KE4 hybrids. You could use a drill press and drill into the heads, and then use like a reamer to ream out a screwing pattern, and then screw these in. Or alternatively, I've seen people use like weights that you would put on a Pine Car Derby car. They have tungsten weights that are pretty heavy. You could use some of those, and again, drill out circular holes that fit the exact diameter, and then epoxy those in. That could work. I'm not going to do that on this build though, although I think that could be a viable choice. The last method is going to be using, this is a pound of lead powder. This is just powder form. It almost kind of looks like pepper, and it's pretty heavy stuff. And I'm going to use, you can use that in combination with some epoxy. And basically what I would be doing is I would be creating a pool of epoxy kind of in these 2 cavities here, and then mixing in lead powder to weigh it down. So I'm going to probably be experimenting with, you can see I've already used lead tape on this head. I will also probably be experimenting with the lead powder method as well. And the reason for this is, so these both cost about the same. However, if you look in terms of weight per dollar, we got about 105 grams of lead tape weight, and we've got like 500 grams worth of lead powder. So price per dollar, the lead powder is a lot nicer. One issue though is this lead tape could be removed, but I don't really know. I think once the lead powder goes on with the epoxy, unless you want to nuke the epoxy, I think it's probably semi-permanent. So with this fire iron head, we're going to try a mixture of epoxy and lead powder. Let's get to it. All right, guys, this is my fire iron. You can see it reads 267 grams. What I've done is I took some lead powder and I poured it into this cavity. See, I'm up to 268 grams. Then I took some two-part epoxy and I poured it into the cavity as well. And then I just took a toothpick and I spent some time mixing it all together. Now, one thing to be aware of a little bit is that the way that I put all this on is somewhat important, meaning the location of this weight is definitely going to affect the center of gravity of this club. Now I've just kind of filled in this cavity, which, you know, to be honest, I maybe should be focusing a little bit more on getting the weight applied here along the heel, along the base of the club, but we're just kind of giving this a shot. So far, this is actually working really well. I've got this up to 268. I did have to use some amount of epoxy and lead powder, but this has worked pretty darn good to get my head weight up. So we're gonna take this one off, let it dry, we're gonna keep moving. All right, at this stage of the game, I'm going to be a little bit conservative and keep it in this kind of 266-ish range because it's always going to be easier to add weight later. It's going to be hard to take it away. So let's keep moving. All right, guys, I want to jump over to the other end. This is my pitching wedge. As you can see, it comes in at about 295 grams. And so this is obviously a little bit heavy. So with the pitching wedge, 295, the 9-iron, just zero it out, at 285, and the 8-iron, 278. These need to come down to that 266-ish range. So we are going to be drilling and grinding into these heads. I've seen people that probably would take a drill press and somehow mount or affix this head in a pretty firm and secure clamping type situation. And then, yeah, you just basically take a drill here and drill some holes. You know, maybe one in the middle, one here on the sides, maybe a couple here along this bottom edge. And again, thinking about center of gravity. One of the thoughts I've heard about these clubs is with these shorter irons, because you've got a longer shaft, you're going to have more club head speed. More club head speed is going to launch the ball higher up into the air. And so you want to be mindful of taking weight out of the lower part of the club head. And if anything, maybe take out a little bit more here so you can redistribute it up top. You want some weight to be up here on that more by the top line to give you some capability to use center of gravity to re-affect the ball flight characteristics. So we're going to be probably figuring out a way to drill some holes out of this. Now I don't have a drill press, So I'm either going to have to just do it by hand. Also, I could probably use I've got a grinding wheel, and I've also got a belt sander. Some of those would probably potentially work, but yeah, let's go ahead and start removing some weight from this head. We want to get this one down by 10 grams. All right, boys, this is a situation where having the right tool for the job is critical. And I don't really have the right tool, but I have some tools that kind of get it done. But as you can see, this head's at 270 grams. This is a 9-iron. Drilled the heck out of it. Here's my pitching wedge. Very proud to see 269 grams. Here's an 8-iron, 270 grams. Here's a 7-iron, 268 grams. Shall we keep going? 266 grams. 5-iron, 266 grams. And a 4-iron. 268 grams. We did it, boys. There they are. They're milled. Basically, I used my 2 drills a whole bunch. I went out and got some new bits. That was kind of critical. I got some of these titanium bits from Milwaukee. So I got one of those in here right now. That was a pretty big deal. And then I also got a real big honking thing. That guy. And then I also did use some of my stinky little bench grinder here. This thing is really not strong enough to do it. It chokes out pretty quickly if I stick the iron in there with too much friction. But it works fine for smoothing out the sole. But we've done it. Our irons all weigh a single heavy. Now I guess that's not necessarily true. As you saw, the shorter irons didn't quite get maybe all the way down. I kind of quit at about 270. I got some that are about 266. But I'd say within 4 grams, I'm going to call it. I'm feeling good about it. Really did have to mangle those wedges. I don't know how some of these guys removed all that weight. Maybe they're doing, I saw somebody mention boring in through the hosel. Maybe I should have done that, but I guess I'm a potato. So anyways, we're good to go there. Next, let's talk about, we're about ready to get these guys rolling. These are some shafts from FST, 115 gram. They're all 43 inches. Now, one thing about these are 370 370 parallel tip shafts. These are 355 tapered heads. So, I need to bore out a little more of the hosel to open up this space. I am going to use a 3/8 inch drill bit, and we're going to drill them out because that's what I got. A 3/8 of an inch is a little bit bigger than .370. I want to say it's like 375 or something like that. I don't know, if you're smart and you can do the math, you can figure it out. but it's a little too big. But so there'll be a little tiny bit of play and slack, but I think that's something that I can live with. Because you know what? These guys are not going in a museum. As you can see, these are like PXG'd up or something, man. But hey, a little work there on the front. We're getting there. This was the hardest part. Removing this metal from these 2 irons was the hardest part. Probably took me just as long, if not longer, to do these 2 as it did to do the other 6. So, onward and upward we go. So like I said, I need to remount these hosels. I start off with a little bit of a smaller drill bit, just to make sure there's no crud. A couple of these actually had like, it appeared to be tip weight, so you can see how much crap's coming out of there. Just make sure I'm down to the base of the hosel, and then I do a visual inspection. That looks nice. Then take my 3/8 drill bit, stick it in, and actually a lot of this, at times it's easier to do this by hand. Kind of clean it off. Maybe a little bit of 3-in-1 oil. Can't hurt. And then it's just a matter of, sometimes I actually just ream it by hand. Just take my hand and spin it. You can, it actually cuts just fine doing this. Yeah, we're getting there. We are getting there. Burst it out. Try it again. There we go. And then I have a shaft here, the 370 tip that I can put in, and I put a little mark on it for when it's in all the way. You can see I'm a little short, so we keep going. Maybe there's some junk in there, it's in the way, most likely. Clean it out with the other one. And there we go. That's how I am reaming these heads out so that they fit on a 370 parallel tip. All right, trimming. This is the Golfworks page for the FST 115 shaft that I bought. Right here you can see stiff, flex, that's what I'm shooting for. That's the one I bought. So the trim code is IR33. You pull up, this is the Golfworks shaft trimming instructions 2020. We go down and we find 7 iron is in this column. IR33 is right here. So that's saying 3 3/4 tip trim. So I need to take one of these, get my Sharpie, measure 3 3/4 of an inch right here, and then trim my shaft. So we're going to tip trim all 7 of these to the exact same place. Now actually, before I go that far, it might be worth thinking about this a little bit more, because the shaft is maybe one area where I can affect the trajectory of the shots. Like I said with my 3-iron, that thing is launching out really low. And on the other hand, I'm guessing the pitching wedge is going to launch really high. So I could maybe use some of these trimming to affect some of that. Now on the flip side though, that is going to change the flex, I believe. So I don't know, I may have to get a little bit more advice from the forum to see what those guys are thinking. But that's how you would do this to cut every shaft to 7-iron length. You'd tip trim it at 3 3/4 inch all the way through. And then you'd butt trim it down to 37 inches, which would probably be the default standard way to go. So maybe I'll do a little more research, and on the flip side, maybe we can just do this tip trimming this way. Okay, this is my procedure for tip trimming. I've got a little rotary tool here, Tack Life, got it on Amazon, and I've got a baggie of these little cutoff wheels, and I just use these to cut through the steel. I think there are plenty of ways to do this. You could use like a handsaw. You can get like a little mini table saw designated for this, but this is the procedure that works pretty well for me.